The model did not fail because it was dumb. It failed because the correct path through the library was expensive to discover. On fluid coding and AI, this is the case study that matters for maintainers, not which model wins, but which API design makes coding agents do better work. Public coding benchmarks are useful, but they answer a different question. SWE Bench asks whether agents can resolve real GitHub issues. Terminal Bench asks whether agents can survive hard command line tasks. Aider tracks whether models can edit code across many languages. Those scoreboards matter. But if you maintain a library, the practical question is smaller and sharper. Can you change your interface so the same agent completes your integration tasks with fewer wrong turns? The first design move is to stop evaluating the model in isolation. Anthropic describes an agent harness as the scaffold that processes inputs, orchestrates tools, and returns results. Their eval guidance says an agent eval measures the model and harness together. For a library eval, that means the setup includes the model, the coding agent, the repository state, the docs, the commands, the tests, the timeout, and the permissions. That whole system is what the maintainer is actually designing against. Start with a small task suite from Real Maintainer pane. Install the minimal example. Add the library to an existing project. Configure authentication. Handle a common error. Migrate from an old API. Extend an example without touching internal modules. Each task needs a starting repo, success criteria, allowed commands, a time limit, expected file changes, and tests. The goal is not to impress a leaderboard. The goal is to reproduce the places where agents waste maintainer time. Then run the baseline before changing anything. Save the transcript, terminal logs, diffs, test results, and failure category. Count turns, tool calls, commands, failed tests, elapsed time, and total tokens where the harness reports them. Also grade behavior. Did the agent read the canonical docs? Did it use the public API? Did it avoid internals? Did it recover from errors, or did it invent a plausible method and keep going? One intervention is a task-shaped command line interface. Speakeasy found that human-centered CLI features can become agent obstacles, prompts block execution, spinners pollute output, and guided workflows leave agents waiting. For an agent-facing CLI, the useful pattern is boring and testable. Add non-interactive flags. Add JSON output. Make validation commands exit non-zero on failure. Return structured error codes with recovery hints. The CLI does not make the model smarter. It makes the correct path cheaper to execute. Another intervention is explicit repo guidance. OpenAI documents agents.md as persistent instructions for setup, tests, documentation rules, and directory-specific guidance. Claude Code has a similar project memory file, but Anthropic warns that this is context, not enforcement. That distinction matters. An instruction file can tell the agent to start from the minimal example, run the doctor command, use public APIs, and avoid internal modules. But tests, schemas, hooks, and CI still need to enforce the rules that cannot be optional. A focus skill is different from a giant readme. OpenAI's skill model uses progressive disclosure. The agent sees a short description first, then loads the full workflow only when it is relevant. Speakeasy reports the same design lesson. Focus skills beat broad, comprehensive ones. Machine-readable docs solve a different problem. OpenAPI, JSON schema, Markdown docs, error catalogs, and an lms.txt index help agents retrieve the right contract instead of guessing parameter names from a snippet. More context is not automatically better context. Anthropic reports that a 5-server setup with 58 tools can consume about 55,000 tokens before work begins, and large toolsets can create wrong tool selection and bad parameters. Their deferred tool discovery approach reduced token use by 85% while preserving access to the full tool library, and improved internal MCP eval accuracy in reported tests. The maintainer lesson is simple: make discovery small, precise, and progressive. After each intervention, rerun the exact same tasks. Compare pass rate, median turns, median tokens, tool calls, retries, failed test runs, and failure categories. Then compare behavior markers, public API use, correct docs read, correct tests run, clean error recovery, and honest uncertainty. This workspace does not contain first-party benchmark results, so the honest claim stops here. The video can describe the measurement design. It cannot claim fewer turns or fewer tokens until the eval artifacts exist. There are 3 easy mistakes. First, treating a CLI as always better than an API or MCP server. It is not. The right affordance depends on the workflow. Second, treating instructions as enforcement. They are not. Guidance belongs in context. Guarantees belong in tests and schemas. Third, treating public benchmarks as local product evidence. They are background signal, not proof that your library is easy for agents. Your own tasks are where the API design question gets answered. The design rule is this: agent-facing APIs should be task-shaped, parsable, non-interactive, explicit, scoped, and testable. That is not separate from good developer experience. It is developer experience under measurement. Better examples help humans. Better errors help humans. Clear setup and reliable tests help humans. The difference is that agents expose every ambiguity faster because they will guess, execute, fail, and retry in public. Maintainers do not need to wait for the next model. They can make today's agents better by designing the path they want agents to take. If this helped you think about APIs as something agents have to navigate, like the video and subscribe to Fluid Coding and AI. The next useful benchmark might not be which model wins. It might be which interface teaches the agent to succeed.